All right, a little bit more about the elements in the next learning objective. The natural elements have variation in the numbers of electrons and numbers of neutrons that they have. And so that creates things called ions and other things called isotopes for each element. We said that for each element, what doesn't vary is the number of protons. Okay? Now this is not hashtag protons. This is not a trending topic on Twitter. This is the number of protons. And this is not hashtag electrons. It's the number of electrons. The number of protons defines the element. If we have 6 protons, then this is carbon. If we have 7, then it's nitrogen, and so forth. And we'll talk a little bit more about that in a second. If we have the same number of electrons that we have protons, then we have no net charge because all of our positives have a negative offsetting them. But if the number of electrons doesn't equal the number of protons, then we get a net charge. For instance, here we have a carbon atom that of course has 6 protons. It has to have 6 protons because it's carbon. But instead of having 6 electrons, this one has 1, 2, 3, 4, 5, 6, 7. So that means that it has an added extra electron. That means it has a negative charge. So this is a C- ion. An ion is a charged particle, a charged atom or molecule. This is a negative ion because it has more electrons than protons. Could we have a positive ion? Sure, we have one right here. Here we have 6 protons. Of course we have 6 because this is carbon. But we have only 1, 2, 3, 4, 5 electrons, no 6th electron. There's one less electron, so now we have a positive charge, and this is a C+ ion, positively charged. And we can have ions of any atom as long as we have fewer or more electrons than we do protons. That would be fewer electrons or more electrons. Some elements like to be ions. Other elements like carbon don't like to be ions very much. But you can make them even if they're not very stable and don't exist for very long. That's one kind of variation that we can have in atoms and therefore elements. There's another kind though. What about the number of neutrons? We said that that was usually about the same as the number of protons. But neutrons aren't charged, they're neutral. That's how they got their name. Neutral particles don't have to be in the same number because they don't offset anything. The protons and neutrons that are in the nucleus, they have mass. Electrons have very little mass. So the mass of an atom is mostly just the protons and the neutrons added together. The number of neutrons that we have will affect the mass or weight. For instance, most carbon atoms in the universe look like this. They have 6 protons. Of course they have 6 protons, they're carbon. They have 6 electrons because carbon doesn't like to be an ion, and they have 6 neutrons. When they have 6 neutrons plus 6 protons, that means that they have a mass of 12 atomic mass units. That's the mass number that we saw back here on the periodic table. 12. 12 is the number of protons plus the number of neutrons, which both happen to be 6. So 6 plus 6 is 12. So we have this isotope or form of carbon, carbon 12. And we put the 12 as a superscript before the carbon to tell us that's the mass number. That's what most carbon atoms look like. But some carbon atoms have an additional neutron. They have 7 instead of 6. So 6 protons, 6 electrons, but 7 neutrons. Now does that change its charge? No. Does it change what it is? Does it make it not carbon? No, it still has 6 protons, so it's still carbon. But now it has a different mass, a mass of 13. So this is carbon 13. Those different things are 2 different forms of carbon called isotopes. Iso is from the Greek word for the same, because these are the same element, but they're two different forms of the same element. And there's another form of carbon that has 8 neutrons with the 6 protons and 6 electrons, and that is carbon 14. Maybe you've heard of that because that's a radioactive element. And unfortunately, we won't have much time to talk about radioactivity, but it's just another isotope of carbon.